Oh.
You're on camera, by the way. Action!
Well, hello. No. What did I
Wow.
say?
Did I show you the South Park episode with
That was not even worthy of a.
What is it?
Yes, it was.
No, it wasn't.
Yes, it was.
National television.
It was
I would
really
say.
good. Why?
Because like if I could say, I don't even know.
Um,
I think something about the.
I would be so happy. Oh my god, yeah. No, there's that one kid.
I remember now.
I don't even know if that kid has a name. He just
apparently
like sounds
has
retarded. He's like, I would be so
imaginary
happy.
Oh wait, it's a cougar, like the animal, not like
Cougar.
not like an older woman. Like
I didn't even think of that when you said that.
at first that's what because my sister was telling me about this and I was like, what? And she's like the animal. It's like, oh.
I didn't even think of that other one.
Well, because I watched this show. It's called Cougar Town.
You would watch that.
You watched it?
It's so funny.
Okay.
It's so funny. Anyway,
Well, I guess I
so,
watched like Teen Mom
he
too,
was
so
like-
I can't even judge.
I was afraid of him. He was like, no, you can't wake him up because then he'll get mad and angry. He could. I was like, I would not want an imaginary friend that I could think would eat me.
It's like Toby.
This kid's
Toby.
Except for Toby actually kills people.
I did it again and you did.
It's because I did like grab
Some
that
paranormal
face.
activity.
I was like,
3 and 2.
Roxy, are you okay? And I swear my aunt's house is haunted.
You swear every house is haunted, so I'm just to the point I don't believe you anymore.
I didn't say your house is haunted.
But everybody else's.
I
house
said
is
my
haunted.
house and my aunt's house is haunted.
And your lake house and Zoe's house.
I've never been to Zoe's house.
Yeah, you have.
I've never been to it.
Yeah, you have.
Whatever.
Because we went in there that one time and she showed me the black stuff in the closet and you were like, ew.
I've never been in her house.
You were there when you saw the black stuff in the closet.
First of all, the black stuff. That just sounds like a
Black
dream.
stuff? Like what?
I
Like she heard
been
like
in
noises
Zoe's
coming from
house.
my closet, like. And at first, like, cause I had raccoons in my house. Well, not in my house, but like in my ceiling, like in the walls and stuff. Cause it like, well, they were technically in my house, but not like in it. They were just like in the middle part. Like,
Just chilling in the ceiling.
yeah, really. No, and like my bed's so close to the ceiling, all I hear is like,
Ugh.
when I'm trying to go to bed, I'm like, oh. And then she heard that, and then she was like, just like a chipmunk or like squirrels or raccoons or something. Then all of a sudden she hears like, and her door opens up, like her closet door, and she's just like,
That's a really
talented
chipmunk.
and she's like, don't you dare move, don't you dare move. She's like, fall asleep, fall asleep. So she was like that. When she woke up and she looked, and there was like black, like, patterns in her closet, and she was like, yo, Griffin, like, your brother, like, come here. And then he's like, it looks like a handprint. She's like, don't tell me. And then I looked, and it did.
That's weird.
It was, and the scariest story she told me, because I've been, like, in her house, like, a ton, like, her mom's house, and there's, like, her cabinets were, like, lined, like, this way, like, lining the walls, and then there's, like, an island, and then there's, like, a doorway, but the cabinets, like, all over, like, they'd be, like, over there. All of a sudden, like, because Henry was in the room over here, her other little brother, there's the opening, and it's just, like, completely open, there's not, like, a door. Henry's sitting there, and then there's a wall, and Zoe's on the other side of the wall, but it's all kind of, like, open, there's not doors, and she knows that it's just her and Henry home. She hears like the cabinet just like open and she was about to yell and be like, Henry, don't get food, we're eating soon. But then all of a sudden she hears like crash and she was like, Henry starts like getting mad. All of a sudden just like crash, 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 one at a time, all of her glassware like onto the floor. But the thing is, it didn't like the cabinets here, it didn't just go like that. It was on the other side of the island and some pieces were still intact. And she said she walked in there, she waited, she sat there just like, and did not go in there until she heard like it go silent. And then she walks in there and Henry's sitting there holding his video game controller just like staring at it, like with this look of like horror on his face. And then she like walks in there, there's glass like shattered everywhere.
So weird.
And her mom's like, hey, put him away, Ryan.
I don't think the cabinet opened itself and just started chucking glassware.
One at a time. So it was all just like, it all went like 1, 2, like in a
That's so
rhythm.
creepy.
And she was like, she told me that like, that was a scary story, but there's like a ton of stories she told me.
Creepy.
I know, man.
My parents went up into town when we were moving to our house. They went up into town and to like the storage unit, which is
like 2 minutes away, but it was like dark out and I was back unpacking boxes in my room. So I like, grabbed the biggest kitchen knife there was and brought it back into my room and set it on the windowsill. And I was like, okay, I'm ready.
Questions? I know I signed a lot of homework. last
I want a French braid. I'm gonna get one.
54.
Okay.
Yeah, number
What?
I think you're doing fine.
Is she wants to do French braid or she wants to get her hair French braid?
I think she wants to get her hair extended.
I think so, she's judging by that. Like, quick segment, I think, yeah, I think she wants her hair. As opposed to, I don't think she'd be that excited to do French braid.
I
That's
think
my
I
hair.
get excited for French
I
braid.
was gonna say you do.
I do because I can't French braid.
French is my own hair.
Here's the question? Okay,
Hey, that was my question. You stole it.
Sorry.
oh, you stole it.
Mine too.
Mine's here, yeah.
What?
It's mine now.
Let's find out where to look first. So, cosine is negative. Do we look in the first quadrant? No. Second? Yep. Third? Fourth? Nope. So we've got two angles, one between 90 and 180, one between 180 and 270. Now, we need to draw a triangle that has a cosine of root 2 over 2. So here's our angle, and we have root 2 over 2. Now, is it obvious what the angle is at this point? Well, we gotta keep doing something else to figure out whether it's obvious or not. Let's Pythag to find the other side. So we'll go root 2 squared plus x squared equals 2 squared. Root 2 squared is 2. Plus x squared equals 4. So x squared equals 2. So x is root 2. What type of triangle is this? How do you know? The two legs are equal. We have an isosceles triangle. If the two legs are equal, the two angles opposite the legs are equal. If we've got a 90-degree angle, the other two angles have to each be 45s. Something to consider. When you normally draw the 45, 45, 90 triangle, you normally draw it 1, 1, root 2. If you look at the cosine of 1 over root 2, think how you simplify that. It's improper to write it like so, right? So what you do is you multiply top and bottom by root 2.
Okay, cool, because that's what I did to get that. Coverage.
And you end up with that. So, if we have the Kramer eyes, we could possibly, this is a could, and I'll put this hypothetically in a bubble, you could possibly see that link. And if you see that link, you're going to find yourself at the familiar triangle. If you don't see the link, you're going to find yourself at the unfamiliar triangle. But in either case, you find yourself at a 45-degree angle. So, we got a 45-degree angle in the second quadrant, we got a 45-degree angle in the third quadrant. So, second quadrant, that's going to be 45 less than 180, 135. And in the other quadrant, 45 more than 180, 225. Theta equals 135, comma, 225. If you ever see this, think back a step. I mean, if you even want to, you could think of it like this. I know that's a really strange way of looking at it, but you could think of it like that. Right? Multiply exponents, add the exponents, a half plus a half is 1, that's the whole. Then you go short, short. Something to think about. Because when you get a situation like this, you might be able to work with it quicker if you have it in the crass form. That form is kind of crass. Do you know what crass means? Someone with who swears like a sailor would be considered crass. So mathematically, that's a little crass. It's a little sailorish, little redneck math there. But this is technically more proper. But sometimes the more proper form makes for more confusing things. So just keep in mind. Okay, other questions? That was it?
Yeah.
That was a huge assignment, that is awesome, you guys are stellar students.
Yeah.
Stellar students, SS. You're my SS group. My stellar students.
I want some pie.
You want some pie, is that what you said?
I
He texted
do.
me and they're like, do you want some pie? Yeah, you're like, I hate you all. And I was like, I hate you.
You want some pie? I really thought he was gonna get you pie. No.
I had some
That's
extra.
That's a bad kind of part. We're thinking that it
It was
actually
blueberry pie.
Don't get McDonald's apple pie, it's gross.
McDonald's and
They've got like
Kramer, stop scratching. When it gets like holiday
Don't,
season,
it's
and
gonna
I'm
get
just
worse.
like, I tried an apple pie, but it came in the form of like a granola bar.
Poison ivy?
No, eczema.
Eczema. Oh, that's like from not enough moisture in the air, your skin dries out, and it gets itchy.
Well, I like the numbing eczema or whatever.
Does it happen every winter?
No, this actually like this just came out of nowhere.
Oh my gosh.
Like I was like, look.
Your French twist.
Nice.
I know, I feel so fancy. Are you fancy, huh? Yup,
Yep.
just a little bit.
Just a little bit.
Hair done, nail done?
Everything did.
Yeah.
I just got my hair done.
I know, all my twins in this class.
me?
Are you supposed to be my
I
twin?
think Lauren is.
Lauren's my twin?
Yeah.
No.
Where did this happen?
I know, I walked in, I'm like,
I
Do I have a
I
stunt
missed that
double?
memo, yeah.
Well, we were changed for the funeral, so she was all dressed up and she had a dress on, kind of
Okay,
dressed up, and we looked similar.
okay.
we did
Kind of.
kind of look similar that day.
Okay.
I'll admit it.
Ew.
I'll admit it.
Okay, so we need to continue moving forward. And I'm gonna, forward is good, yeah. I'm gonna pick up pieces in 56. One piece is gonna be a final discussion of shading inequalities. We're gonna do a couple examples to, one, remind us of how to shade inequalities. Two, circles are a particular one that's interesting. And then another one that we're gonna do is to do some triangular areas, which will be fun, because well, some of you like geometry. If you happen to like geometry, I like geometry.
I hate geometry.
Yeah. So we're
The obtuse angle.
right.
Du-du-du-du-du.
Yeah, it's gonna be kind of stuff like that. Now, let me give you an example of an inequality, just to remind yourselves of what we're encountering in these types of situations. Oh my gosh, are you kidding me? How hard is it to find a problem with that? So here we go. Start with an example, a simple one. Y is greater than or equal to x squared plus 4x plus 2, and y is less than minus x plus 1. And there's a picture. Now, a couple things you're going to have to be able to do to address a question like this is to know which equation deals with which graph. So look at the two equations, look at the two graphs. The first equation is the parabola, because he's an x squared. So he's my, I'll label this y1 and y2. How about that? y1 and y2. So here's my y1 and my y2, a line. He's just degree 1, so he's a good old-fashioned line. How else could you have told if not by the shape of the graph? By the dashing of the graph? Notice the dashed graph is the less than, and the shape, the fold one is the one that has equal to, right? So you don't even have to know parabola, you can just do it by dashed or undashed, in some cases.
There's like, I'm already there.
Alright, okay. Now, the y is greater than or equal to the parabola. So y's greater than mean, if a y is greater than, we're talking big y's, right? So that's above. So we're above the parabola. So I'm going to do the crosshatch shading technique, and I'm going to shade everything above the parabola with vertical lines. Now, in addition to being above the parabola, we must be less than the line. Y's that are less than are low. So we have to be under the line. I'm going to use horizontal for under the line. And if you are over the parabola and under the line, you are in this region here. Feel familiar? Familiar enough to do a problem? Hopefully. Now, let me give you an example that involves a circle. Remind me of a circle equation. Like this, right? Now, what if we had less than? Our circle is less than a certain radius. Here's our circle. If we're less than that radius, where are we? Kramer?
I got no.
Yeah, if we're less than the radius.
If you're not outside, you're
Yeah. That's good. I mean, that's good on your feet, like action there. That's good. I think you'd be outside and then inside.
Is it true?
I don't mean to make fun of you. Let's think about this. We're less than a particular radius. So if here's a particular radius, if our radius is less than that, then we're tinier. All things tinier would be the inside. So that means we're less than a particular radius, we're inside the circle. If we would have something like this, oops, I should put an equal to because I drew a solid line. If we're greater than a certain radius, so imagine we are bigger than the radius of equal. Bigger radius, outside. Because you could imagine, imagine how you could draw that shading. You could draw every single circle with a bigger radius, and if you drew every single one, it would just become a solid brick of shading. Right? In the same way, if you drew every circle with a smaller radius, there'd be infinitely many of them, and they'd make this solid sphere. Kosher? Okay. So let me go like this. Here's another problem. Whoops. X squared plus y squared is less than or equal to 16. Y is less than or equal to x. Here's the picture. We're not going to be able to tell by dashing on this one, unfortunately, because neither of these are dashed, but we ought to be able to tell by shape given the two equations. Right, and I know it sounds stupid, but this is important stuff. So, looking at the two equations, the top one is the bottom one is the line. Okay, good. Now, let's use our shading technique. We are less than a particular radius. If our radius is tiny, that means we are inside the circle. I'm going to go horizontal shading for that. So the only question is whether we're above or below the line. Our y is greater than the line. So greater y's lie above. So we go above the line. And the region that we are in is that guy right there. Where we are above the line and inside the circle. Straight? Good. Triangular areas. Now, as soon as I say triangular area, you should think of something.
Yeah, face that tight.
1/2 base times height. So, if you know the base of the triangle, you know the height of the triangle, you know the area of the triangle. Because you multiply the two numbers and divide it by 2. Right? It's a tough game.
Nothing?
You're joking?
Yes.
Okay, good.
I don't
I don't understand. If you literally don't understand, you can prove it to yourself this way. I'll go back to roots. Watch. This will be fun. See, we'll go 2 meters by 3 meters, right? And each meter can be broken into 1 meter chunks, and each of those can be broken into 1 meter chunks. And then you see how many meter squares you have. You notice you have 6 meter squares. You notice that this means that the area of a rectangle is just base times height, right? And then you realize that when you chop the rectangle in half, you get 2 triangles. So, area of triangle is base times height divided by 2. In case you forgot the rationale, there it is. And how cool is that? And as well, if you have like not right triangles, that works too, because remember, you can take any rectangle, you can take any rectangle, chop off a corner, take that corner, sorry, I'm new with this wedding ring thing, and move that corner to the other side, and you make a parallelogram. So the area of a p-gram is base times height, and then with parallelogram you can also chop that guy in half, and you still get 2 triangles. Right? So it's not just right triangles that it works for, it actually works for all triangles. Say what?
She was just like laughing to herself.
Isn't it?
So weird. It's funny.
It's weren't we in geometry last year?
Yes.
Yes. Nice. Voguing.
I was like showing him your butt or something. And I was like, what are you doing?
Yeah, please don't look at
Okay,
my.
I gotcha.
Please don't look.
She's just showing off.
No, that just means you get to take me to Red Lobster tonight.
Oh.
So I can show everybody off and be like, yeah, that's right, I'm gonna do my own hair. Nails done, hair done, everything big. Everybody
Okay.
knows that song.
Especially because I got my hair done. So.
Now,
Exactly. I'm wearing
now
a dress.
I'm gonna give you a triangle. And I'm gonna give you some information about the triangle. 42-degree angle, 12 inches over here, 16 inches over here. Now, okay. Is the area of this triangle 16 times 12 divided by 2? No, why not? The height's not 12, because how do we measure height? Straight up and down. Because if you don't, you can be as tall as you want. Right? Right? That's the short answer. Yeah, you want to be 7 feet tall? Just measure like this, right? So we had to put our foot down at some point and say, okay, height, perfectly up and down. So we need to find that guy. But I think we can. True. Because, yes, as soon as I draw that height down, notice you have a triangle inside a triangle. And the triangle that's inside the triangle is a right triangle, which affords you the opportunity to use either Pythagoras or SOHCAHTOA. SOHCAHTOA looks really nice here, because with 42, h, and 12, we can find h. So relative to 42, h is our opposite. Relative to 42, 12 is our hypotenuse of this triangle within the triangle. So, what did sine? Sine of, I love how you guys are taking this so sarcastically. This is great. Because I mean, add emotional content and it becomes more memorable, so please, this is great. We can. Sine 42. H over 12. Right? Okay, that's solvable, right? With at least, with the calculatrice. Yeah, so, Skylar, if you can, sine of 42, just to start. It's gonna be point something, something, something. Because we know sine, think about this, hold on.
Hold on.
You know that, there it is, right, there's a sine graph, right, and you know sine goes between 1 and -1, so you know you're gonna get point something, something when you put in sine 42. And what do you get, point? 0.669, that's point something, something. Mm-hmm. Okay, then we cross multiply, h equals? H equals?
I'm ready for you.
Sorry.
What is it?
8.02.
8.02? Are we done? We solved for our variable, are we done?
No.
No, the question was, actually I didn't put the question. The question was to find the area of the triangle. Now that we have the height of 8.02, now we can do the famous base times height divided by 2. 16 times 8.02 divided by 2. Area equals base times height divided by 2. That's 16 times 8.02 divided by 2.
I have a question.
Mm-hmm.
Because you cut pretty much cut the triangle in half to form the height.
Yeah.
Why wouldn't the base be divided? Like, why wouldn't it be 8?
Okay, that's a good question. Yes, and I can give you an answer. Let me draw a triangle like this. Is that going to cut those? No. When would it? The answer, if you had balance here and there. So if you're in an isosceles triangle, where you have balance, when you drop down with a perpendicular, it's not just a perpendicular, it's a perpendicular bisector. Only in an isosceles triangle. Is this an isosceles triangle?
Yes.
We have no idea. But we do know its area. It's 16 times 8.02 divided by 2, which makes 64.16 inches squared. Damn is right. Remember, the sign that came out is reasonable. The sign between 1 and -1. And you can see it now. It's not just, you don't have to remember it, you can see it. It's easy to remember things when you see them. People remember faces. Right? So we just put a face to a name. Right? In a strange way, we put a face to a name. Isn't that weird?
I know your dad, but I've never seen him.
Right? we were, believe me.
I was gonna say that. I know who you are. I just don't know your face.
Yeah, and you know what? If you're talking mathematically, now I'm gonna play devil's advocate here,
I
mathematically.
love that phrase,
Okay.
devil's advocate.
What does that feel like a class that you took in the past? That feels like what? When we deal with equations, that feels like algebra, isn't it? Algebra. I mean, can you come up with solutions for this? Like, just I mean.
2 and 2.
Okay. Another solution?
4 and 1.
1 and 4, 4 and 1. Anybody want to be eccentric? 8 and a half?
Yeah.
How's that? Right? There's an infinite number of them. You could graph them, you could look at a picture, it would show you something. You could put a face to a name. You could also put a face to a name this way. This problem, algebra, check out this problem. We just put a face to a name. Algebra, geometry, same problem. Kinda neat, eh? Eh?
Hey,
Right? You can know people by name, you can read books, right? You can know people by name without their face, or you can know people by face without their name. You can walk by one street.
That's the name of the face.
I
Skylar.
know your name, I don't know your face.
I ain't trying to be rude, but I know your name, I just don't know your face.
Also, the red, with red.
Or vice versa, okay, here we go, 56.
9 and 10, but I wrote it all down.
Okay.
So, just give that to your mom.
56.